Hi Akshat, how are you doing?
Hi, sir. I'm good. How are you?
Very good. How was your test?
I'm pretty good, sir. We finished trigonometric functions and we're moving on to trigonometric identities and proving them and working with various formulas. So I thought it would be best to touch upon it before it actually begins.
Sure, sure. So can you share with me your next chapter and then I'll prepare you for that.
Yes, sir.
You can share the screen.
You can see, right, sir?
Equivalent trigonometric functions. Yeah. So, okay. So what is theta plus pi, theta minus pi, theta plus pi by 2? Okay. Continue. Go to the next page. Continue. Okay. So these diagrams. Okay. Summary. Even and odd functions. Perfect. This is
Yeah.
called co-function identity. Correct. So basically, you're looking into these three things: principal angles in quadrant 1, 2, 3, and 4. Correct?
Yes, sir.
Right. Right. So I can explain you these topics, and then we'll go through some questions from your book. Okay.
Okay, sir.
So let me share with you a whiteboard.
Yeah.
You can see the board, right?
Yes, sir.
Okay. So we'll begin with Castro.
Yeah.
Okay. Any point which is on quadrant 1, what are its x and y values?
All positive, sir.
All positive, correct? We are looking into x and y values. They are all positive, correct? So I'm writing positive, positive. That's what I mean, right?
Yes.
In quadrant 2, the x values are negative, but the y values are positive, correct?
Yeah.
In quadrant 3, both are negative. And in quadrant 4, we have positive value for x and negative for y, correct? So
Why?
these are x and y values, which are positive or negative. In general, let me also show you a visual saying that if there's a point P here, and the coordinates of the points are x and y, and the distance from the origin O is r, in that case, dropping a perpendicular from P to the x-axis will give you a triangle. Let's call this as M. Now, in this particular triangle, what is OM equals to?
So it would be your x value, right?
And PM is Y value, correct?
Yeah.
If the angle, which is the principal angle here, principal angle is always measured from the positive x-axis counterclockwise is positive, right? So let's say this
Yeah.
angle is theta. So in that case, tell me, what is sine theta equals to?
So sine
What
theta
will
would
be
be
sine?
positive value, right?
Y over
Yeah.
R.
Y
This is
over
the
r,
ratio.
opposite over. Yeah.
Y over R. And from here, we can say what Y is equal to, right? We can rearrange and write Y equals to R sine
Sine
theta.
theta.
And if we have cos theta value, then cos theta is basically
X over r.
adjacent over hypotenuse, x over r. So the x coordinate value is basically r cos theta. Does it make sense to you?
Yes, sir.
Correct? R is always positive. Now, let us say that r is equal to 1. That is, we're talking about a unit circle.
Yeah.
In that case, what is x value equals to? R is 1, so x is cos theta, correct?
Cos theta. Yeah.
And what is y equals to? Sine theta.
Sine theta.
So basically, x and y are cos theta and sine theta. You understand now?
Yeah.
So any point P, if I take up any point P, then the coordinate points are basically r cos theta,
And r sine
r
theta.
sine theta. And if r is 1, in that case, as you know, in a unit circle, r is 1. In that case, it will be exactly sine theta cos theta. Otherwise, it is scaled by a factor of r, how far it is. You get the idea, right?
Yes, sir.
Now, important thing here is that the sign of cos and sine will basically depend on the sign of x and y, that means, correct?
Yes, sir.
So if you consider that part, in that case, in quadrant 1, sine will be positive and cos will also be positive. Is that clear?
Yeah. Both
In
positive.
quadrant 2, since we have negative for cos. Only thing which is positive will be sine, correct?
Sine. Yeah.
Here, both are negative, correct? And in
Yeah.
this particular quadrant, cos will be positive, correct?
Positive.
Now, you also know what is tan theta, the third trigonometric primary ratio. Tan theta is the ratio of sine theta and cos theta, correct?
Yes, sir.
When will tan be positive? Tan will be positive if both are negative or both are positive,
Both are
correct?
positive.
Now, in
Yeah.
this quadrant, tan is going to be positive since both are negative, correct? Both
Oh,
negative
okay. Yeah.
means tan is. So that is how, and here also tan is positive. We get our cast rule. You understand the cast rule?
Yes, sir.
So we have the cast rule. Let me write C, A, all are positive, sine is positive, and tan is positive. So the basic foundation of cast rule is the quadrant itself, that the x and y values in two quadrants they are positive and two quadrants they are negative, correct?
Yeah.
So basically, every trigonometric ratio is positive in two quadrants, all in one, quadrant one, and the others
Yeah.
as shown here. Is that clear to you?
Yes, sir. Got it.
So that is the first thing which we need to understand. Uh, Now let's move forward and see how sine and cosine functions are, which are even, which are odd, right? Let's look into even and odd part of this particular function. Let me clear the screen. Now we're looking into even function and odd
Yeah.
function. Now let us sketch the sine graph. So this is the sine graph. Okay. Let me draw the horizontal x-axis and let me draw here the y-axis. It's a periodic function, it repeats as you know. So
Yeah.
this is the origin. What do you notice? Well, the graph is not very accurate. However, you know this will be 1 and that will be -1 since sine theta value is between plus and -1. Right?
Yes, sir.
What kind of symmetry do you see for sine theta?
It looks odd symmetry, sir.
Yes, because it is symmetric about
The y-axis.
origin.
Yeah.
Sine theta has odd symmetry. It is
Sir?
symmetric about, yes,
Can you say symmetric about the y-axis, or would that be
no,
incorrect?
that is wrong. In
Right.
that
Yeah.
case,
So
it will be positive, right? So
yeah,
symmetric
yeah. Just origin. Yeah.
about, we say the point, to be very specific, origin,
Oh, okay.
correct? So it is symmetric about. That is to say, if I take a point here and a point here, we'll have the image reflected about the point origin. Is that clear to you?
Yes,
Now
sir.
this we
Clear.
can also write as sine of minus theta is basically equals to minus sine theta.
Minus
That
sine
is
of
the
theta.
meaning of odd symmetry. What is odd
Yeah.
symmetry? Odd symmetry is f of minus x is equals to minus of f of x.
F of x.
You get the idea.
Yeah.
So sine has odd symmetry. You can see it is positive here, negative here, correct?
Yeah.
It's positive here, negative here. It has odd symmetry. Is that clear to you?
Yes, sir.
Now let's look into the cosine graph. So I'll again sketch a function which is similar to the sine function, right? So cosine and sine are actually the same functions. Only thing is
Phase
cosine
shift, right?
leads, yeah, phase shift.
Yeah.
Cosine leads and sine lags, correct? So that is the only thing. So in this case, we know the cos function actually starts with a maximum, correct? So let me just make it like this and like this. So as you can see, cos function is symmetric about the y-axis. Do you see that?
Oh, okay. So that's when it would be correct. Yeah.
So, and you will also notice that cos of minus theta is basically equals to cos theta. That is what even symmetry means.
Sir?
Yes,
So it would mean that f of negative x is basically f of x, right?
it means correct. F of negative x is equals to f of x. It is symmetric about
The y-axis.
the y-axis. Is this clear to you? So we have
Yes, sir.
understood the symmetry of sine and cosine. Now, let's talk about the symmetry of tan.
Okay.
So tan theta is basically sine theta over cos theta. we are going to learn a very important formula here, which can be applied in general. Now, as far as the symmetry goes, sine theta has odd symmetry,
Odd.
correct? And this
Yeah.
has even symmetry. So if you divide even with odd, what do you get? Odd.
Yeah.
So if any function has, because see, if you're looking for f of minus x, in that case, the numerator will be minus of f of x and the denominator will be f of x, correct?
F of x.
I
Yeah.
mean,
So you'll get an
I should
odd
write g
function.
of x, right? I mean,
Yeah. Yeah.
that ratio, correct? So basically, you see it is negative of that function, right?
Yeah. Yeah.
Let me write g and h. Let me clear this to just make it very clear to you. Of tan theta. So tan theta basically equals to sine theta over cos theta, correct?
Yes, sir.
Now sine of minus theta and cos of minus theta, if we write, then what do we get? We get minus sine theta
Minus.
over cos theta, correct?
Yeah.
Which is basically minus tan theta. You understand now?
So tan is also an odd function, right, sir?
Yeah, tan is also an odd function, right? So tan also has an odd symmetry.
Yeah.
Now let's also explore tan further, because I find that students are not very clear about the tangent function. The graph of the tan function is kind of like this. It has vertical asymptotes when cos theta is 0, right? Because the denominator is cos theta, correct?
Yeah.
And of course, cos theta cannot be equal to 0, correct?
0. Yeah.
So we have this vertical asymptotes as pi by 2 and minus pi by 2. And we have a 0 at the origin, correct?
Yeah.
You see the graph is symmetric about the origin, right?
Yes, sir.
That is what we mean, right? So it repeats. And one thing very important to understand here is what is the period of tan theta?
Sir, would it be pi over 2 minus negative pi over 2?
It is pi, yes. So when you do
Yeah.
the difference of these two, right, you get pi as the period of tan theta. And
Yeah.
the period of sine and cosine is what? 2 pi, right? They repeat
Yeah.
after 2 pi. So that is also a difference between tan and sine and cosine. Is that clear to you?
Yes, sir. Sir?
Yes.
So how would you write the domain and range of a tan function?
Okay. So tan function domain, if you want to write, you can say theta belongs to real numbers where theta is not equal to odd multiples of pi by 2. So we'll
Oh,
say,
okay.
yeah, 2n, we can write 2n plus 1 becomes it odd, right? Of
Yeah.
pi by 2. You understand?
Yes, sir.
Theta
Because
is not
it's
equal.
recurring, right?
Yeah, because, yeah. So let me just go back and rewrite this properly. So where theta is not equal to, well, let me clear all this. So domain of tan theta, very, very important.
Yeah.
So domain of tan theta, as you see, it has vertical asymptotes at odd multiples of pi by 2. Is that okay? Not even multiples.
Yeah.
At even multiples, it is 0, correct? So
Yes,
odd
sir.
multiple. Odd multiples means 2n plus 1 times pi by 2. Is it okay? So
Yeah.
theta is not equal to this. Right? So you can say
Yeah.
this where theta belongs to real number. Is that okay?
Yeah.
This is very important. And of course, range is no limit, right?
Yeah. No limit. Yeah.
Y belongs to real numbers, all values. Is that clear to you?
Yes, sir.
So
Clear.
that is the domain and range of tan theta. Very important question.
Yeah.
Now let's talk about the identities.
Yeah.
We'll begin with the co-function identity. Do you remember that?
I have a vague memory of it, sir.
Okay, what do you remember?
Sir, I think it is used to find like related angles, the cofunction identity.
Not exactly. I will not show you what cofunction identity is. Let us
Okay.
say we have a triangle whose sides are A, B, and C. Okay. Now, if this angle is theta, then what is the other angle? The other angle will be 90 minus theta, correct?
Okay. Yeah. Yeah.
In a
I'm
right
starting to
angle
remember.
triangle, correct?
Yeah.
Now, in this particular case, what is, let me write tan theta first. What is tan theta equals to? Tan theta is B over A, correct?
B over A. Yeah.
And what is tan of 90 minus theta? A over B.
Oh, A over B. Yeah.
It is reciprocal. Okay. Now, let me also write what is cotangent theta. Cot is reciprocal of tan, right?
So A over B, right?
B over A. Oh, sorry, A over B. Yeah, yeah, yeah. Sorry. Let me just reverse this. Cotangent theta is A over B, but cot of 90 minus theta is B over A, correct?
B over A. Yes,
What
sir.
do you notice?
Oh, so they're related. Yeah, exactly.
Yeah, that is what I wanted to write. But
Yeah.
so basically, what we have learned here is tan of 90 minus theta, it's all degrees here. I should write pi
Yes,
by
sir.
2 in radians, is equals to cot cotangent theta. Is it okay? So
Okay. Yeah.
when working in radians, you have to write tan of pi by 2 minus theta equals to cot theta.
Cot theta. Yeah.
Now reciprocal is also true. That is cot of 90 minus theta is same as tan of theta. Is it okay?
Yes, sir.
Okay. Now let's again look at the same diagram with sine and cosine.
Okay. Sir.
Yes.
My assumption is that I think what we found for tan and cot, right? I think it will also hold for sine and cosecant, maybe. That's what I assume.
Okay. So let's see. What is sine theta equals to? Sine theta is
B over C.
B over C.
Yeah.
So, and what is cos of 90 minus theta?
Cosine of 90 minus theta is A
You're
over C.
looking from this.
B over C, sorry.
So this is B and that is C.
Yeah.
You see both are same.
Oh, okay.
So you get the idea. So we
Yeah.
get, these are called co-functions, right? So you can say, you can also say sine of theta is equals to cos of 90 minus theta, or you can say cos of pi by 2 minus theta is equals to sine theta. Is that clear to you?
Yes, sir.
Similarly, if you look from the other side, in that case, you will also come to know that sine of pi by 2 minus theta will be equal to cos of theta. Is that clear to you?
Yes, sir.
Correct. So these are the co-function identities. Of course, the reciprocals means secant pi by 2 minus theta will be equal to cosecant theta. You understand?
Yes, sir.
So all these functions, pi by 2 minus theta, will be equal to their counterparts, like in this fashion, right? Do you understand?
Yes, sir.
Cosecant pi by 2 minus theta will be secant theta. Is it clear? So all. So that is
Yeah.
what we call as co-function identity.
Okay.
Clear?
Yes, sir. Clear.
Perfect. Now let's look into, so we have worked on the quadrant 1. So basically you're saying that if we have a triangle, let's say this is our triangle.
Yeah.
And if we kind of flip, that means if we make this as y and that as x, do you see this? These two triangles now?
Yes, sir.
Correct? So if this angle, one of them is theta, then the other angle is 90 minus theta, right?
90 minus theta. Yeah.
Because I'm taking this as theta. You get the idea.
Yes, sir.
So this is 90 minus theta, the whole thing, right? You get the idea.
Yeah.
Correct? So in that, co-function identities work and we have the relations. Perfect. So you've understood this part. Now let's
Yes, sir.
move to the second quadrant, right? So I'm erasing this part and we'll now see what happens when we are working in one triangle in quadrant one. So that is the angle is theta for us.
Yeah.
And the other triangle is now in quadrant two, but with the same angle theta, with the horizontal x-axis.
Oh,
In
okay.
that case, what is this angle? 180 minus theta or pi minus theta. Is that clear to you?
Sir, just a quick question. So on
Yes.
both ends, they both are there, right? So from you saying the green triangle to the end of the red triangle?
One triangle is the green triangle. Let's say OAB,
Yeah.
and this is OA dash B.
Okay.
So these are congruent triangles, correct?
Yeah.
We have the same length OA and OA. We are just moving the arm, terminal
Yeah.
arm OA all along the circle. Now it has earlier, it stopped here, right? 90 minus theta. We worked that
Yeah.
out, correct? Now we are moving it further and we are going to, I went straight down there, 180 minus theta. In that position, you see the relative positions are exactly same. So in that case, what is sine of 180 minus theta equals to? And what is cos of 180 minus theta? And what is tan of 180 minus theta? You can write pi by pi.
Yeah. Sir,
Yeah,
before we attempt those, right? Just wanted to ask. So
yeah,
you see the angle you drew, right? 180 minus theta.
yeah, yeah,
That's from the positive x-axis to where
yeah.
the,
So always you have to draw principal angle,
yeah.
which is counterclockwise from positive x-axis. Is that clear to you?
Yes, sir. So
Counterclockwise.
sir,
As
it's to the starting of the red line, right?
yes, it is still the starting of red line is what. So we are seeing
Yeah.
that angle. We are saying sine of 180 minus theta is equal
Oh,
to
okay.
what in terms of theta. You get the idea.
Okay. Yes. Yes.
So
Yeah.
in terms of theta, we'll compare with the green triangle, which is in quadrant one, where
Yeah.
all the values are positive.
Yeah.
So important thing which you've learned here is that in quadrant two, let's write down the Castro. In quadrant two, sine is positive, others are negative, correct?
Yes, sir.
So this value will be positive, other values will be negative. Of
Yeah.
same, because the triangles are congruent.
Okay. So this only holds for congruent triangles, right, sir?
Yeah, I mean, whatever triangle is formed will be congruent because it is the
Congruent.
same
Yeah.
terminal arm. So we are rotating the same terminal arm.
Yeah.
Is that clear to you?
Yeah.
So it will always be congruent, right? So we have respective positions. So if this is, let us say this position is x, y, in that case, this position will be minus xy. Is that clear to you?
Yes, sir.
So the only thing remaining positive will be with respect to y, which is positive, and that is sine.
Yeah. Because we're in quadrant two.
We are in quadrant two, correct?
Yeah.
Now, if I have another triangle in quadrant two, if I move further, let's say over here, right? So now this angle will be how much? Theta plus pi, right? Pi
Yes.
plus theta, correct? So for that, what ratio will be positive? Tan ratio, and
Tan.
others
Yeah.
will become negative. So you get
Yeah.
the idea, right? So in this
Yes, sir.
particular case, let me now erase this, and we say tan of pi plus theta will be equals to tan theta. Sine of pi plus theta will be minus sine theta, correct?
Yes,
And
sir.
cos of pi plus theta will be minus cos theta, correct? We're looking
Sir.
at, yes, sir.
So we relate these co-function identities back to the first quadrant where everything is positive, right, sir?
Yeah, yeah.
Okay. Yeah.
So I'm just making with the same color. So we're talking about these two angles now. Do you see that?
Yes, sir.
So in that case, we see these identities. Perfect. Now,
Yeah.
if I move it further, let us say in this position, correct? So this angle is how much? 2
2
pi
pi minus theta.
minus theta. So here only cos will remain positive, right?
Yeah,
So
yeah.
if I write sine of 2 pi minus theta, it will be minus sine theta.
Minus
Easy
sine
to
theta.
remember, right? Do you see that?
Yeah. Yes, sir.
Just basic concept. Cos will remain positive and the other will become negative. Cos also means secant, right?
Secant. Yeah.
Reciprocal of cos, correct?
Yeah.
Is that all clear to you?
Yes, sir.
Now, all this is absolutely clear. Well, it is easy. When you do pi or 2 pi plus or minus,
Yeah.
the orientation is same. X remains X, Y remains Y, right? Now we'll consider another case where we will actually use 90 plus theta. Okay, so another example,
Oh,
I'm just picking it up.
yeah.
Yeah. So if I have a triangle, let us say this is one triangle. Let me make I mean, I erased everything. Okay, doesn't matter. And let's say if this angle is theta and the other angle I want to make is 90 plus theta. Do you see these two triangles?
Yeah.
So if this angle is theta, I'm making this angle as 90 plus
90
theta
plus theta.
or pi by 2 plus theta, right?
Yeah.
In that case, what happens? We'll apply both the Castro
Yeah.
and the cofunction identity. So cos of pi by 2 plus theta should be equal to what? Tell me.
So, sir, we're in the second quadrant, right? So
Yes.
cos would be negative. So it'd be negative cos theta.
You are right. Negative, but sine theta, because it has to become negative.
Oh,
You understand?
yeah, yeah.
So it is negative value of sine theta. But sine pi by 2 is going to be positive. So that is going to be same as cos theta because everything here is positive. Do you see that? So when I write theta, all are
Yeah.
positive.
Sir,
Yes.
how come cos became sine and sine became cos?
Co-function identity because this angle theta is now
Oh,
here. Do you see that?
so we just applied what we learned from start to now, right?
Co-function.
Okay.
So this
Yeah.
theta is now that angle. Do you see that? So it's a co-function. You're looking at from the different direction. Opposite
Yeah.
side becomes adjacent. Adjacent becomes opposite. You get the idea.
Right. Yeah.
So tan pi by 2 plus theta will be I'll have to write minus cos
Yeah.
theta. Is that clear to you?
Yes, sir.
So likewise, you can work with pi by 2s. You understand? So these are important identities which you are supposed to learn in this particular unit. Is that clear to you?
Yes, sir. Clear.
So that is how you will actually do it. So I hope this concept is clear.
Yeah.
Right? So we can actually write, as you can see, some angles in many different ways. Because you can
Yeah.
write using co-function identity or function identity or so many different ways you can
Yeah.
actually write an angle. And that is what critical part of this unit is. So if I have, let us say here, right? And let's say this angle here is, so if I have this angle is, let us say 2 pi by 3. That's
Yes, sir.
principal. So we can say that sine 2 pi by 3 is equal to what?
Sine pi by 3.
So yes, so the related accurate, you're right. So this is pi by 3, correct?
Yeah.
Is it okay? So this is equal to sine 2 pi by 3 will be equal to what? Tell me.
So sine 2 pi by 3 is in the second quadrant, right? So it's
So this is
positive.
pi, correct? So it is pi
Pi,
minus
yeah.
pi by 3. Is that okay? So you are
Yes, sir.
correctly saying actually the answer, but I want to write as, it is same as pi minus 2 pi by 3. Is it
2
okay?
pi by 3. In terms of the related
Clear
acute angle,
view
right, sir?
at sine pi by 3. Is that clear to you?
Yeah.
So that is how you can actually relate using pi minus theta concept. So this angle
Yeah.
is same as this, right? If I would have written cos of 2 pi by 3, you will write this as equal to minus sine of you could write like this also, pi by 2 plus theta. You understand?
Yes, sir. Pi by 2 plus theta.
So you could use that concept also, right?
Yeah.
Right. Or if you want to maintain cos with cos, in that case, you will write this as minus of cos pi minus 2 pi by 3, which is minus of cos
Minus cos pi
pi
over
3.
3.
Is that clear to you?
Yes, sir.
So that is how you can relate the angles using any one of those identities which we learn.
Yes, sir.
Correct? So that is what you will be working with. I'd like you to actually do some questions and then we'll discuss further.
Yes, sir, for sure. Yeah.
So okay, can you now share with me your learnings for the day?
Yes, sir, for sure. So today, I know in last April we touched upon trigonometry when I was doing grade 11 functions, right? And we talked about co-function identities and double angles and stuff like that. And today, when we're actually doing it, I actually forgot some of it. So it was good to remember, and I can definitely use this because we haven't learned this yet. So I'm ahead of the class. So I appreciate that. Yeah.
Thank you then. All the best.
Thank you, sir.